Hi everyone, welcome to our first set of solutions to suggested exercises. So the exercises I gave for you for this week were the following. Draw the truth table of the following properties. Are any logically equivalent? And we have this set over here of not F or G, not F or G, etc. Now, before we even begin, we must be clear on what I'm asking you. So, do we know what logical equivalence is? So we've seen that in the reading, that two statements are logically equivalent if they always have the same truth value. Now the next question is, how do we know if two statements always have the same truth value? In other words, how do we know if they have the same truth value under every possible condition? And this is where truth tables come and really help us. And as we'll see, truth tables are really useful to also help us determine if an argument is valid or not. Okay, so let's get to the exercises. I realize that I've given you the names for the statements as F and G. And using F is going to be a little bit complicated when we're going to assign truth values. So let's change it to H for this video. Okay, let's start with not F or G and draw its truth table. So how do we do it? So the first step is to notice the simple statements and the logical connectives of the complex statement. So what are the simple statements here? What's the simplest possible part of this complex statement that says not H or G? Well, it's H and G. These are the simple statements. And what are the logical connectives? Well, you might have noticed that it's the not symbol and the or symbol. And once we've done this, can we get to the second part, which is to actually fill out the truth table, going from the most simple to the most complex, as we'll see. And you do this until we're done. Now I should note something, which is that if you haven't done this, you should really pause the video and try to do it on your own. It's the best way to learn. You try, and once you get really stuck, then you can look at this video for the solution. Okay, trusting that you've done this, we can get started. Okay, so the simplest statements, or the simplest elements of this complex statement are H and G. So we start with drawing the truth values for these, and these are going to determine all the possibilities that we should consider when determining the truth value of not H or G. Now, what are the possible values that H and G can have? Well, H can be true or false, so we just denote it like this, and G can be true or false, right? But we still haven't exhausted all the possibilities that they can have together, because here we have in the first row that H is true and G is true, and in the last row that H is false and G is false. But we still have the possibility where H is true and G is false, and of course the converse where H is false and G is true. So now we've really exhausted all the possibilities of that H and G can have. Okay, so now we want to remember go from the most simple to the most complex, and the next step in the most complex is the not H. Okay, so let's draw the truth table for not H. Okay, so how do we do that? Well, what elements are we going to draw upon? We're going to draw upon the first column, which is the truth value of H, right? So we look at the first column and we see, okay, if H is true, then not H is false. And that's since H is true in the first column for the first two rows, then not H is going to be false for the first two rows. Similarly, if we looked at row 3 and row 4, where H is false and false, then not H is going to be true and true, right? If I say Piper is a dog, when that statement is true, if I say Piper is not a dog, then that statement is going to be false. Okay, so we've looked at H, G, and not H. What is remaining? Well, the or part. And the or on the left side, so one of the disjuncts is not H, and on the right side, the other disjunct is G. And as you'll notice, we have all the elements in place already. So we have in the second column, we have G, and in the third column, we have not H. So we can easily just look and fill out the truth table for not H or G. So let's look at the first row, right? G is true, and not H is false. So true or false is true. If I say Piper is a dog or the sky is yellow, right? If Piper is a dog but the sky is blue, that statement is true. What about the second row, where it's false, false? False or false? Well, if you say to falsity, it's going to be false. And similarly, in the third row, if you say true or true, then the disjunction is going to be true as well. And then in the last row, we have the same situation as we had in the first one, where it's false or true or false. And so we know by the truth tables and from the other exercises, and really intuitively if you think about it, that false or true is true. So actually, we're done now. We've filled out the truth table for not H or G. Here with the little arrow, you see that the last column, we're done. But right, we're not enough to figure out if it's logically equivalent to some of the other complex statements that I've given you, because we haven't filled out those truth tables yet. So we're not going to do all of them in this video, but I hope to give you the basis to do all of them. We're going to do one more, namely we're going to do, first let's put the table here just to make it simpler, and what we're going to do is look at not H and G. And the reason I do this is because we actually have all the elements in place to figure out the truth table of not H and G. So let's add a column, and we see that it's actually the same elements that we're going to need as we did to figure out the truth table of not H or G. We just have to look at the second and the third column. So let's figure it out. True and false. Do you remember what that is? Well, it's false. If you have one conjunct that's false, that makes the whole conjunction false. Let's look at the second row. False and false is also false. True and true is true. And false and true, just like the first row, is false. So we're done with filling out the truth table for not H and G. Easy, right? Now let's think. Are not H or G and not H and G logically equivalent? And hopefully you notice, first of all, if you don't remember what logically equivalent is, look again at the definition. Two statements are logically equivalent if they have the same truth value in every possibility. So here we have four possibilities, which are represented by the rows. And let's look at the first row. Not H or G is true and not H and G is false. So do they have the same truth value? Well, no, they don't in this possibility. So they don't have the same truth value at every possibility. And as you'll notice, they won't have the same truth value in the last row either. They do have the same truth value in rows 2 and 3. But the definition of logical equivalence tells us that for two statements to be logically equivalent, they need to always have the same truth value. So the answer to this is no. Okay, so we won't go over the other two, but hopefully this has given you enough background to go through and figure out if all the statements in the suggestive exercise are logically equivalent. Thank you.